This is IBM Museum, and here I am with one of my Model 60s up on the bench. And this is an ESDI model. This would have been the 8560-071 for the 70 megabyte ESDI drive that's on the system. Now, this particular drive is actually one of the larger drives. So it doesn't quite match up with that submodel, but I've been working on a little bit of code for the ESDI controller. Years ago, I'd planned to go through and get some utility that would go through and detect things about this ESDI controller that's on versions of the Model 60 and Model 80. And those are the towers like you see here. And so I'm going to get turned around and I'll show what that ESDI controller looks like and just give a little bit of background to what I am looking to do. And I've got my camera system kind of played over to the rightmost just to get the Model 60 up in pretty much the center of the screen. I didn't want to obscure any portion here. Of course, this machine is kind of a working example. I mean, I would go through and normally I've got the front cover pulled off. I would go through and put ribbon cables behind the drive cage and things like that. The interesting thing was I found the easy way to go through and move files around with this is to connect up the 4869-001 external drive from IBM. And this is the 360 KB drive. It actually goes through I thought, well, if I'm a Model 60, why not? It's got the passive bay adapter that goes through and passes down the signals for that B drive down to here and out the back for this to be cabled in. And of course, I've got it on. I don't have any diskette in the drive or anything like that. Later on, when I go to work with it and transfer files around between other 60s, I'll get set up this very same way. I do have a few of these passive B drive connectors that I can go through and just to make that process a little bit easier on me. But the ESDI drive is this full height. And of course, with a single drive, it is towards the back of the unit. If you had another ESDI drive, and I've got another Model 60 that's got two ESDI drives on it, that drive would be in this forward bay here. And then the controller card is normally in the topmost slot, slot 8. And it has the connectors for the control and data, and the control connector for the primary drive is here, and then the secondary drive, if you have one present, is here. So normally you have the two cables together, and this is a 34-pin cable. I think this is like a 20. Yeah, it's got 10 per side, so that's a 20-pin cable. And each one of these smaller cables goes to the drive itself that it controls. And whereas the data cable is actually shared between the drives, you have the primary drive on the end of the cable, and it actually has a twist in there like the old style diskette drives do. But this is the ESDI controller. I don't have my ring light on, so hopefully I'm not getting the reflections that I don't want in this instance. But it has on here, and these two ROM chips here are for a BIOS ROM extension, meaning that the adapter itself has to go through and has to modify the system BIOS or be in there that just to tell the system basically how to run this board. We'll get looking at those versions in just a moment. But they're marked with an FRU code on there. And these are actually the later version. There were 2 releases of this, just separated by a few months back in 1987. And then the chip that I'm really was kind of focused on, and here it looks a little bit scratched up as it is for what I have in my hand. I should have probably found a better example, but it is the ESDI microcode or ESDI controller microcode. And it's kind of hard to read, but that is the FRU there is 15F, and then it's 6807. And that's a particular microcode version that I wanted to go through initially and do a utility that was calling ESDI level without the second E in there, basically in the style of the SCSI level program that I'd gone through and reworked a little bit, updated before that took on a life of its own, and others came up with more advanced utilities that was working on that. But that was to tell the microcode level on the IBM SCSI adapters. Well, I thought, let's go through and let's write some software for the getting the microcode version on the ESDI controller. And I got sidelined, and I don't know what it really was all those years ago, but I suspect I just ran into some roadblocks and kind of went through and had some trouble. And I learned actually in that time that it was just easier to pull these ROMs off since I wanted to get the contents anyway of the different versions. And right on in the code, there's human readable strings of which microcode it is, which version it is. So that turned out like super easy. But I still didn't have software to run it. And so this code that I'm doing now is a little bit more of the focus on continuing on that, just to get to learn what this microcode is in by means of software. You wouldn't have to look at the chip and see the code on there. We could run a utility that goes through and it just queries and gets the microcode level in software, and it would tell you what you have. So let me get set up on the screen here and pull up where this is on the ESDI controller page. And I can probably go through and get to interact with this to show what is shown above this. But here is the microcode, and over on the left, and of course the blue links are where we've got that on the Ardent tool to be able to go through and download that and effectively go through and upgrade the microcode on your board. Because as you can read below that, there is some text here to the troubles. I mean, these are actually effectively bug fixes that occurred from IBM to go through and fix various issues. So the IBM goes through there and lists these, and typically they had an EC notice and engineering change, and they went through and informed. They did a write-up of when that problem could occur and what the correction was. In other words, in this instance, it was to go through and to get a replacement ROM version. And in particular, this occurred for the very last version. And I've got an adapter. It looks like IBM depended on Phoenix Software, writers of BIOS code and other things, to go through and to be a supplier for those chips. If the engineers figured out that there was an issue, you could go through and get that newer version of the microcode that was put on your board, and to avoid these particular issues. And I'll include the link in the video description, and I'll go through, and once we run through the code, I'll actually show a little bit of this table. Now, there's a couple versions I don't have here, and I don't know if those are released to the wild or not. It may have been like version 2 was before the PS2s were even released in April of 1987. So that was probably suppressed, and they probably started out with a version 2 immediately, since they'd already gone through and basically done a bug fix version to go through, and they got that in service. And then through time, they went through and had these other bug fix versions. And some of these microcode versions are more common than others that you see them. And the really funny thing is, whenever I hear of someone having one of these ESDI controllers on a system, on the Model 60 or Model 80, I go through and tell them, hey, can you look at what microcode version you have? Just so I can get a kind of a running idea. And then basically I'm looking for the 2 versions that are identified here. I know the FRU, but I don't have those ROMs myself on any of my boards to go through and copy them. So I'm kind of looking out and saying, hey, if I find a version out there, it'd be good to capture it as well. And that takes going through, in this case, of pulling the ROM off the board and reading it with an EEPROM reader. And generally, it's not too much of an issue, all things considered. But, that may have a little bit of a danger aspect of getting you to get the ROM in there backwards or something like that. You'll burn it up, yes. But the page above this, and here we have the BIOS extension ROMs. I talked about the 2 chips that are on towards the back of the bracket, and they are interleaved chips. We have all the sizes of those listed as far as going out there, being able to order them from part suppliers, and to being able to program. You grab the image and program those of your own. Now, I do have both versions of that. Most of my adapters have the later version, and there's not much even difference in date there, just a few months. Even for the initial version, again, being out there before the PS2s, the initial PS2s were released. But up above that, we have outlines of the adapter, what goes through for a later version and an earlier version of the adapter, based on the ROM orientations and what we've been able to determine from chip dates and things like that. But I will include a link to this page, and then it has the hard links for going to the things like the microcode ROM. And we're going to go ahead and leave that particular page up, or leave it in that position as we go through, and we switch back to this view. And probably for a part of this, I will end up, and just to avoid obscuring things on the screen, I will go through and turn off my webcam. But let's get switched over to the video capture. And I'll go through and grab a hold of my keyboard as well. And so I've got some items I've put on there. And it's even funny because you can see the new items at the bottom, and you can see the items above that ESDItest.com and ESDI level.debug, the ESDI level out. Those are done back in 2005. So a good 17 years ago, almost in this case, looks like September for those dates, back in 2005, is when I got initially looking at some of this information and just could not get far enough along with it. And I've done a little bit of basics for this demonstration, and from here it's real easy for me to go through and to do a little bit more involved code. Now, in the background, it was seen that I have now on the screen, I was identifying as the ESDI info. I think with the level of the information that's going to be provided by this utility, it's better just to consider that it's not going to just tell the microcode level. So as I have on the background screen, I'm going to go through and probably ultimately call that ESDIInfo. And so initially here, I'm actually going through and doing debug scripts and piping those into just using a text editor and piping those into the debug program. And there's a lot of tracking you have to do of little things, but for little utilities, it's rather easy. And I'll probably go through and do get over to using the Microsoft assembler for actually the bigger programs, just to make it easier with macro statements and things like that. There's a little bit more better management in that case. You don't have to track the addressing and things like that. But this is one of the script files I've done, and this in particular is for the microcode level. And so I just go through and a text editor and give it the name of what I want the executable, how that is organized. It's assembled at a certain location, and going through and putting code in there. Some of the code is maybe a little bit redundant, but it's just best to go through and get the stuff tracked in there better. So there's no ambiguity in the utility. Just, I mean, you might as well for just a little bit more space on the drive. But this is the basic functionality of the code here. And the I'll actually show this in operation of the program of a debugging utility called CodeView from Microsoft, going through and single stepping through the code and getting me the results. But basically, I'm going through there and I'm using a BIOS call that I've seen online, just as a reference of what I was trying to do, and this is probably from years ago what kind of roadblocked me or just caused me to where I didn't have enough time at that point to focus in a little bit more deeper on the code, but it's missing a critical aspect. So with help of my friends, I've gone through and analyzed this a little bit better to know what it needs in this case. But I'm going through and just having a buffer space, and it goes through and performs a BIOS call on the system, and really goes through and interacts with these ROM BIOS extensions, since that defines what this adapter does basically to the system, and to go through and to get that microcode version off of the other ROM. So once I go through and I've typed out things, I'm sure I've got the addressing. This is a multi-step process sometimes of me going through and putting code in and figuring out I've got to do this offset a little bit more. But this is assembly language. And so And I've actually got a mouse driver set up on the system. I could be using a mouse in these full screen programs. It's loaded the driver and everything else, but a lot of time I understand these just by even the full screen stuff like edit and code view and stuff like that by the keyboard shortcuts. So I'm going through to pipe in that script file, SCR for script, and I'm doing that symbol to go through and pipe the results. In other words, have the debug program act on that script that I've written. And it goes through and assembles things and gives me kind of the readout of how that code is. And I can kind of confirm looking at particular points to see, okay, yeah, that's the right addressing that I've got set up here. And so the program is ready. And then with the code view utility, I'm going through and just saying, hey, run it under code view, which is another full screen program. And at some point here, I'll have to hide myself because I'm concealing the registers. And I don't know if I can basically, maybe I can drop my image down in the corner. Maybe that will be good enough because I'm going to pop up the registers. And most of what I need is there. Enough on the screen. So that's probably fine there. So now that I have the registers displayed, I'm going to go through, and I have to go through and even time how long it takes to run this. But I'm going to do the Alt-R and then go down to execute. And that'll go through and actually single step through this code that I've written. And so just do enter and just kind of sit back as it goes through. And it's stepping through various places in the system, checking certain things, setting things up just for the ultimate what I'm trying to do. I'm just trying to simply gain what that microcode level is in software. And it's just amazing the steps that have to be gone through. Now, this DC00 segment that you see on that left-hand column, that is actually it's running the code of the BIOS extension. I have the identical board to this, same EEPROM versions actually in the machine itself. And I think it's upwards of like a minute, maybe even two. I don't know. It goes through, and you can just, for people that are familiar with assembly language, they can see some of the statements that are being run there. The jump zero, the compare, just it's going through and setting up a table basically of the information, and I'm going through and just interested in a particular part of that. They really should have timed this out to make sure that I could go through and just what I needed to say at times. And I'm trying to do some loop structure now. And the ports, the register ports that you see over on the left-hand side, in particular the 3510 and 3512, those are IO port registers on the ESDI controller itself. And basically, it's a system communicating with the ESDI controller over that IO port range. And I could have gone through if I'd have known it was really this long. I could have gone through and done the pause. But this is kind of cool just to go through and get the microcode level. This is the steps that are required. You know, it's not really any way of doing a shortcut. And it's no wonder that when I was capturing the ROMs that were on my adapters, that it was just the easier way to do things for me rather than go through and suffer. And all that code is basic on the system. I only wrote a small portion of this. Now it gives us a notice that the program is terminated normally, and it has 5 in parentheses. It actually has a return value, and that's in the AX register. That 4C is that terminates the DOS program. And then it goes through, and in the AL register, the lower section of that AX register has the value of 0.5. And I'm going to press just the space bar just to kind of get cleared on the screen. I may go through and, you know, why not? Let's go through and just go back to kind of restart to, oh, and that cleared a little bit of that. So I could do, let's do F5 runs through it. And that's not single stepping. It goes through and just does it all at once and gives you the result. So we've got the same result. I'll press the space bar. This shows it a little bit better. In fact, I think that the instruction, yeah, it's just highlighted the instruction that's the step after it terminates the program. And so, and that didn't show the results of my buffer that I was wanting to show. That buffer, I've got the 0 zeros there. That's where the program was putting my information in there. And then I'm going through and I'm extracting the place where that value of 5 ultimately is for denoting that microcode level. And in fact, let me get back to, yeah, so I'm enough out of the view for that as well. So on the adapter I have here, it's got that version that's the 4th one down, that 15F6807 is the EEPROM that I have on this adapter, and it's an identical adapter that's in the machine, and that is the revision 0005, and of course it's doing the leading zeros. The main indication I did from is in this instance was, hey, that's ultimately a single digit. From I've seen everywhere from 2 to 7 at the highest, so I know that I can fit in that field and be a return value to the program for this little stub. And of course, my longer program is going to have a lot more information that it prints out too, and it's not necessarily going to. It will have the same value returned, so people can use it in batch files and things like that to go through and as a way to be able to get that microcode level for whatever use. But this is in software, this went through and it did the microcode level. It's on the adapter. All those steps did out. So I'm going to go through and I'll write the longer program and have some strings that it prints out and things like that, other information it does, and then go through and release it so where people can run this on their own. They don't even have to look at the ESDI controller anymore. As long as they have an operational system with that controller in there, they can, and of course, normally it has the drive to boot from as well for the system as well. But they can run through that software to determine the microcode version for themselves. So if you enjoyed this content, thought it was entertaining, informative, whatever, go ahead and click on that like button, please, and subscribe to my channel if you have not done so already. But this is IBM Museum. That's all I have for now. Thank you.